Hello, everybody. Last day of reInvent. How are you guys all doing? Yeah? Did you enjoy the party last night? Cool. Yeah. So welcome to EC2 Foundations. My name is Raj Pai. I lead the product management team for EC2. So quick show of hands. How many of you are new to the cloud? You know what AWS is, but some of these terms are still kind of new to you, and you want to know what EC2 is and how it works. OK, a few of you. How many of you are EC2 users and want to know what we've introduced over the last several months or last year? Really, what's new? All right. OK, that's great. So we're going to break this talk apart in 4 main areas. We'll talk about the EC2 resources. These are the instances that compose EC2, the storage and networking that go with it. We're going to talk about how we at AWS build AWS to be available and tips and tricks and abstractions that you can use to help make your apps resilient on our infrastructure. As your apps get more sophisticated, we're going to talk about some of the abstractions around deployment and monitoring and administration that we provide to help you scale up your use of compute on the cloud. And finally, we're going to talk about how you can optimize your spend on EC2. So with that, I'm going to start with the EC2 instance, and I'm going to spend a lot of time on this topic because it's really the core of our offering here. So what is EC2? What is the EC2 instance? EC2 stands for Elastic Compute Cloud. As you would expect, we have racks of servers all around the world in availability zones, which are 1 or more data centers in regions all across the world. And within each rack, we can have dozens of servers. And on each server, we have hypervisors that carve up the resources, the memory, the CPU, the networking, the storage of those boxes into virtual machines or guests. The EC2 instance is our name for the virtual machines that live on EC2 hardware. So 12 years ago, we really had a few main tenets. One was we wanted customers to be able to scale up or down quickly as needed. And we wanted to let them be able to pay for only what they use. These were pretty revolutionary at the time. Up till then, you had to procure data center space and hardware and make long-term commitments, capital expenditures. With EC2, we made this more of a utility-based model. It was one of the first AWS services after S3, and this was in 2006. The other tenet we had was we thought there was a core building block for compute. We called it the EC2 instance. We later named it M1. It had 1 vCPU and 1.7 gigabytes of memory, and we thought that was a great form factor for most workloads at the time. Well, today, the first 2 tenets still hold as much as they did back then, having a utility-based compute model that scales up or down as you need. But as customers brought workloads to AWS, we realized that they have a lot of distinct needs, and we had to provide a lot more selection to make sure they got the right price and performance for the various workloads that they needed to run at scale in the cloud. Since 2007, we've introduced 175 different instance types. And you'll notice that towards the tail end of that, we've really accelerated our growth. And that's due to some innovation and investment we've made in our architecture. So you know I talked about that hypervisor that runs on the EC2 instance. Well, in addition to virtualizing the CPU, it does a lot of other things historically in most virtual machine deployments. It also virtualizes the network, packet processing. It also virtualizes storage, both local and remote, the I/O processing. It also secures the box. It also provides a control plane for managing the instances on that host. Now, all of that software historically has run on the host, which means it took up resources that we couldn't make available to our customers. And it also could impact performance because it took up some overhead of the CPU on those hosts. Well, several years ago, we've decided to modularize all these components and make significant investments in our own custom hardware. So we built hardware offload devices in conjunction with a company that we acquired called Annapurna Technologies, where we took all these modules, we modularized the virtualization stack, the network, the storage, the security, we built it into hardware that we put on the motherboard in these offload devices. What this means is that we could offer all the resources of the box to you and have a very lightweight hypervisor. What this also meant was that the hypervisor was optional. You could bring your own hypervisor or run operating systems or software that couldn't run in a virtualized environment due to, for example, licensing restrictions. That enabled us to have a bare metal offering that we talked about last year. But the third benefit is, because we modularized this virtualization stack, we didn't have to go and re-qualify this on every new platform that we introduced. We used to have to optimize it to make sure we were eking out every last bit of performance, because every part that we didn't optimize wasn't available to customers. But now we could bring new platforms online, embed this ASIC, and then these platforms could very quickly be launched to customers. So I talked about the 175 different instance types we have. What is an instance type? You see this kind of cryptic word on the side, M5D.extra-large. That is the API name of an EC2 instance. Let's break that down. So we have a lot of different instance families. It turns out that different workloads have different needs. Some workloads need more memory. Some workloads need more storage. And the way that we express these needs are in ratios. General purpose workloads tend to need well-balanced memory to vCPU, whereas memory optimized may need more memory per vCPU. Each of these different ratios, we've defined families that are ideal for those sort of use cases. The M stands for our multi-purpose or general purpose family that has a good balance of CPU to memory. The 5 is a generation number. As we introduce new processors, new networking technologies, innovations in the way that we build our hardware for performance, we increment this version number. M5 is our 5th generation multi-purpose instance. The D represents additional capabilities that we optionally make available to our customers. In this case, the D stands for local high-speed NVMe disk. We have M5s with disk and M5Ds without disk. And finally, extra large. This is what we call a t-shirt size. So we have different sizes of each of these families. And the difference between one size and the next is that they have the same exact ratio of resources, but the bigger size have more of them. A 2 extra large would have twice as much CPU, twice as much memory, twice as much storage as an extra large, but it would be at the same ratio. What runs on the EC2 instance? We have Amazon Machine Images, or AMIs. That's the configuration, the software, the OS, any software packages that are required to launch an EC2 instance. We have a bunch of these that are Amazon maintained across a broad set of Linux and Windows images. We even have our own Linux distribution, which is one of the most popular distributions out there, Amazon Linux. We just introduced a new version, Amazon Linux 2, that has 5 years of long-term support. We have a broad set of partners who offer every conceivable operating system and software package on the AWS marketplace. And you could build your own images. You could take something from on-premises. You could take one of our images. You could build in the configurations that you want and bake that as an AMI. You could have that private to your account. You could share it with other accounts. You could even make it public to the community. So on our instances, we offer a broad set of processors and architectures. By far, the vast majority of our instances have historically run on Intel x86 processors. But even that's changing. This last month, we introduced AMD EPYC processors to our most popular instances. And just this week, we announced and launched our own first AWS-built processor, the Graviton processor, that's based on a 64-bit ARM architecture. We also offer a broad range of GPUs and FPGAs for those accelerated workloads that could benefit from highly parallel execution. I'll talk a lot about those. Our goal is to offer the right compute for every application and every workload. So let's start with the workloads and work backwards to the types of instances that we offer to meet those needs. General purpose workloads. These are things like enterprise apps, caching fleets, web servers. For those, as we talked about a little bit earlier, we have the M5 instance, which is where a lot of customers start. It's got a good balance of compute memory and networking resources. Remember I told you about the first M1 instance that had a 1 vCPU and 1.7 gigs of memory? The largest size of the M5 has 96 VPUs and 384 gigs of memory. We've come a long way. And then as we introduce new generations, we generally are able to provide pretty significant improvements in cost. The latest generation M5 has a 14% improvement in price over performance versus the previous generation. That's pretty typical as we introduce new generations. We've announced that we have variants of the M5 available with AMD. With a lot of general purpose workloads, they're not compute bound. They don't necessarily need the highest frequency parts. The AMD EPYC 7000 runs at a slightly lower frequency than the Intel Skylake, but for workloads that aren't compute bound, you just see a price decrease. It's 10% cheaper for that variant. And we also have these available with high-speed local NVMe disk. So one thing, especially with general purpose workloads, is we notice when we look across the EC2 fleet that most instances aren't very busy. If you take a look at this chart, this represents the number of instances running at various CPU utilizations on EC2. On the left-hand side, you'll see that most of our instances are running somewhere between 0 and 20% CPU utilization. It's a bimodal distribution. Obviously, on the right-hand side, you're going to have some extremely compute-intensive workloads, analytics, maybe Bitcoin miners. But the majority of the usage is on the left. So how can we take that as an opportunity to lower prices for our customers? Well, we have a class of instances, our T instances, that offer a burstable general purpose performance. What this means is that we set a baseline level of performance that we guarantee with the instance, and you're able to burst to full core when you need this. What this means for us is we could pack a lot more of these onto a host, because we know that not every customer is bursting at the same time. And then most of the time, over 95% of the time, customers see the full CPU. Now, this has been extremely popular because it's our lowest price instance, under $4 a month. This is great, but what about that one time where I have a flash sale and I'm going to be running above that baseline for a couple days? Well, typically we would throttle you down over time to that baseline. They said, well, you know what? That makes this a no-op for me, because I know it won't happen often, but when it does, I don't want to have my customers experience that throttle. So we've introduced a new capability called unlimited mode that's built into T3, where we actually look at your baseline performance over a period of time. If it exceeds the baseline performance guaranteed by the instance size, we actually are able to look at the difference and bill you a small true-up to meet that amount. Turns out, customers hardly ever run into that, but they love the fact that they have that insurance policy that their end users won't experience bad performance when they run out of burst credits. So that's available by default on T3s. You can turn it off. And now we've also introduced or announced that we're going to be bringing in AMD variants of the T3 instance as well at a 10% discount over T3. Super excited about that. Final general purpose instance I'm going to talk about is our A1. This is our the first ARM-based instance in EC2, and really the first widely available ARM-based instance in the cloud. These are built using our Graviton processors that we've developed in-house with our Annapurna Labs team. So many of you are writing software using open source packages or interpreted languages. Really, most of the software written in the last 10 years is architecture agnostic. So for these workloads, we've actually taken our experience in seeing how customers use the cloud and looking at the hardware that we have in our data centers and really tried to optimize what are the core what is the core functionality that we need in silicon for these processors. And by doing so, we've been able to have an offering that really optimizes the price and performance for these scale-out general-purpose workloads. I was just talking to the CEO of SmugMug the other night at dinner. He's already testing the A1 instance, and with his PHP stack, he was able to get a 40% improvement in price performance by just switching to the A1. And we think this is going to be fairly typical of these interpreted stacks or open source packages that could run on multiple architectures. So really encourage folks to try these out. And we're going to be listening very intently for feedback because we expect to continue to develop our own processors moving forward. So how do you choose between these? Well, if you have workloads that tend not to use the full performance of the box, we have the T3 instances, which are optimized from a price performance perspective for most of these bursty workloads. For workloads that need a good balance of compute and memory, but tend to run higher in terms of how much CPU you need, we have the M5s or the M5As, that's the AMD variant. And finally, if you have architecture-agnostic workloads that are scale-out workloads, we strongly encourage you to try out and give us feedback on the A1, because we think you could save a lot of money using some of these newer instances and processors that were really designed for the AWS cloud. So we talked about general purpose, but there's a lot of other types of workloads, and one of them is workloads that depend on high amounts of memory. And for these workloads, the key factor that they look at is minimizing the dollar per gig of memory. These are things like in-memory caches or high-performance databases or analytics. And for these, we have the R5 instances that have an 8-to-1 ratio of memory to vCPU. In comparison, our M's have a 4-to-1 ratio of memory to vCPU. So for these instances, we also have an AMD variant, the R5A. And we are launching very shortly a bare metal variant of the R5, which, as I mentioned before, is useful for those workloads that may have licensing restrictions that prevent them from running on virtualized hardware. There's a lot of databases that may fall into that category. But many of our customers told us that the 768 gigs that you get in R5 is a lot, but what about for my really big scale-up workloads? So for those, we've introduced the X1s and X1Es. The X1s have 2 terabytes of memory. The X1Es have 4 terabytes of memory. And these are optimized for in-memory caches and SAP HANA type workloads. Now, one thing you've noticed is that we have 6 different sizes of X1E. It turns out that these have a 32-to-1 memory to CPU ratio. There's a lot of databases that are licensed per core. And these databases tend not to be compute bound. Customers told us, like, for those databases, can you give me a 32-to-1 ratio instance where I only have to pay for that 1 vCPU and I can have a big working set, because I don't tend to max out. So that's why we introduced these smaller sizes of X1s from 122 gigs of memory to 4 vCPUs. And people tend to run databases like SQL and Oracle on those, saving greatly on their total cost. Because most of the cost for those workloads is in the price of the software, not the price of the instance. But for scale-up workloads like HANA, customers just keep on getting bigger. We have customers that are already reaching the ends of what they can do on an X1E in terms of working set memory. So for them, we've introduced even larger sizes with up to 6, 9, and 12 terabytes of memory. These are SAP certified. They're built with custom Xeon scalable processors that we've co-developed with Intel. And they're native to AWS. Unlike other providers who provide high memory offerings that are hosted and kind of connected to their data center via their equivalent of direct connections, these are actual EC2 instances. They're simple to manage. They're part of your VPC. They're flexible to scale. They resize in minutes. And we have even bigger variants, 18 to 24 terabytes, coming in 2019. And we actually have customers already interested in purchasing those. So talked about memory. Let's talk about those workloads that have requirements around high-performance disk, both SSD and magnetic. Let's start with SSD. So there's a lot of workloads like transactional workloads or high-performance databases that need the most IOPS you can get. And we provide those with the i3 instances. They provide up to 3.3 million IOs per second, and they're also available in bare metal. These instances are the foundation of our VMware Cloud on AWS offering, along with some of the other instance types. And these are some of the first instances where we virtualized that storage I talked to you about in the Nitro system. Because we were able to put that in hardware and really optimize the heck out of it, we were able to get almost 10 times as many IOPS versus the previous generation. And you're going to see that performance moving forward, because by moving some of this technology to hardware, we're able to get performance orders of magnitude over what anyone else can get. Some customers need really high-speed sequential throughput, and we have two offerings for that. We have the D2, which offers the lowest cost per gigabyte of spinning disk. It has up to 48 terabytes of hard drive space, and that's ideal for data warehousing and HDFS, log processing. Some of our customers told us that there's these new emerging workloads around big data and Kafka and MapReduce that they don't need so much disk, but what they need is more memory and more compute for that same amount of disk, because there's a lot more processing that happens. And for those, we ship the H1s. Finally, let's talk about some of our compute-optimized workloads. Things like batch processing, distributed analytics, where you really want to get the most of the CPU. And the place most customers start is our C5s. This is another example where we've custom designed a processor in conjunction with Intel to meet the needs of our customers. These have a 2-to-1 ratio of CPU to memory. And like the other Skylake processors, support AVX512, which is our Intel's vector extensions that are optimized for increasing operations across vectors and across inference. They actually have twice the performance versus their previous generation AVX technology. And these are also available with high-performance local disk. So if you look at the CPU itself, you'll see that there's like a 25% price performance improvement over the previous generation. But when companies like Netflix also take advantage of the vector extensions, they're able to see much greater performance improvements. They were able to see 140% performance improvement by leveraging the AVX512 technology that Intel provides in these chips. So always encourage folks to always look at our new generations and the microarchitecture changes and the additional enhancements that we bring, because they could really change the way that your workload operates. Just this week, we introduced a new C5, the C5N, which offers the fastest networking in the cloud with 100 gigabits of network bandwidth on the largest instance size. No one else has anything like this. This is ideal to lower the cost of your network-bound workloads, especially when you have clusters of instances, for example, in HPC configurations that need to have really high throughput and really low latency between nodes in the application. It also allows you to have extremely high-speed data transfer from S3 for analytics and big data workloads. We tested this ourselves, and we were seeing 97 gigabits of throughput. There's a little bit for the TCP overhead on top, loading up data from S3, which is fantastic for doing processing on large amounts of data. Unlike what people do on premises to get high bandwidth, these are just EC2 instances. There's now special network topologies. You don't have to have a network architect manage how you can get to a large number of nodes. They just work. And as we're talking about specialized workloads, there's some workloads that need even higher performance than you can get with a 3 gigahertz part. These are workloads that need the absolute highest single-thread performance, like electronic design automation or multiplayer gaming. And for those, we offer the Z1D. For these workloads, often you're paying per vCPU for the software, so you want to maximize what you get out of the software. And with a 4 gigahertz part, the fastest in the cloud for sustained all-cores turbo, we're able to do that with these also custom-designed chips that we've worked with Intel on. Epic Game uses these to minimize the latency in their multiplayer online games, which I'm sure many of you are familiar with. But compute isn't just about CPUs. It turns out there's some fundamental limitations on what you can do with a CPU. There's only so many cores you can put on a die. There's so many ALUs, or arithmetic logic units, you could put on a core. So you're only able to typically have tens to hundreds of cores on a CPU. Enter accelerated computing workloads that use GPUs and FPGAs. These are scenarios like machine learning, high-performance computing, and graphics. I'm going to talk about some of the work we've done and some of the instances we provide that meet the needs of these workloads. So as I mentioned, CPUs are ideal for general-purpose use cases. But what about when you have to run thousands or millions of operations in parallel? Well, compared to a CPU, a GPU can have thousands of processing cores. A typical GPU can have 5,000 cores, and you can have 8 of them on a server. An FPGA, or field programmable gate array, can have millions of programmable logic cells. So these are ideal for these highly parallel tasks. One of this is GPU compute. These are scenarios like training machine learning models, or running HPC simulations, or rendering 3D. For these workloads, we have the P3 instance, which runs 8 NVIDIA Tesla V100 GPUs, providing up to 1 petaflop of computational performance. An extremely fast throughput between the GPUs using NVLink for those jobs that require multiple GPUs working in conjunction. These support all ML frameworks and all model types. Just this week, we introduced the most powerful GPU instance yet, the P3DN. These instances have the 100 gigabits of networking that I mentioned before in the C5N, which is ideal for training machine learning models extremely fast, because you can then scale the training across multiple nodes. You can have hundreds of nodes training a model in minutes versus hours. And in these applications where you need this sort of model training, time to train is the most significant factor that our customers are looking to improve. In addition to the networking throughput, they have twice as much memory on board each GPU, so you can load even larger models onto the GPU. And the host system has 50% more vCPU and over 50% as much memory, so you can do a lot more pre-processing of those models before bringing them into the GPUs. So really excited about that, and we actually have a ton of interest already after announcing that these are coming out. So you typically think about GPUs for graphics. We offer instances focused on graphics with the G3 that runs the Tesla M60 GPUs. These are ideal for workstation, graphic visualizations, encoding. Halliburton uses these for oil and gas seismic exploration. We just introduced a new size, the G3S, which is ideal for cost-optimized workstation performance. These can run up to 4 monitors at 4K resolution. But you don't always want a dedicated GPU instance. Sometimes you just need a specific amount of acceleration on a normal EC2 instance. And for those, we have a couple options. We shipped Elastic Graphics a little bit earlier, I think it was last year, that lets you attach a fractional amount of GPU to do graphics acceleration, maybe for your gaming or rendering workloads. That way you don't have to buy an entire GPU. You can buy, like, say, a C5, then add just a slice of a GPU to it, optimizing your spend. Just this week, we introduced the same capability for inference. With elastic inference, you're able to reduce your deep learning inference costs by up to 75% by adding a fractional size of a GPU to any of your EC2 instances. This way, you don't have to go and buy the P3. You can go and figure out what sort of resources your host needs for processing, how much inference you want to do on the box, and then launch that instance with just that amount of inferencing. Anywhere from 1 top to 32 tops of inferencing. And finally, I'm going to talk about F1s. These are the first programmable hardware instances available in the cloud. For specialized applications like genomic sequencing, engineering simulations, you can get orders of magnitude improvement in your algorithms by programming them to FPGAs on the F1 instances. We've seen applications where you can get well in excess of 30% the performance of a CPU. Now, you may say, I don't know how to program an FPGA, right? And many of us don't. Well, what we've done is we've worked with a bunch of partners to build these accelerations and offer them on the AWS marketplace. So you don't need to know how to program an FPGA to get a 30-time improvement in your transcoding. You can just go to the marketplace, download the image, launch it on an F1, and away you go. You're saving a lot of money for that sort of compute with something you can only really do on the AWS cloud. So in conjunction, we offer a whole lot of categories of instance types meeting different workload needs, whether they're general purpose, memory intensive, storage intensive, GPU accelerated. We offer choices of processors. We offer high amounts of networking for those workloads that need it. We offer you the ability to add fractional amounts of accelerators like GPU and graphics, GPU for graphics and GPU for inference. Together, this allows us to provide platforms that meet the needs of virtually every workload and every business. So now I'm going to talk a little bit about the other resources that you use in conjunction with EC2, starting with storage. So I mentioned a number of instances that come with local storage. You have your I's, your IO optimized, your D, your dense storage instances, your H's, and then our M's, C's, and R's all have variants with local high-speed NVMe disk. These are non-persistent data stores by default. The data is not replicated, but of course you can have your own abstractions on top that replicate it like you would do on an on-premise environment. And they're available with both SSD and spinning disk. These are really popular for low latency applications where you don't necessarily need that data to persist. You don't need that durability. But most of our customers use local storage in conjunction with block storage as a service, Elastic Block Store, EBS. With EBS, you can create and attach storage with an API. You can optimize the amount of storage you have, and you can detach and attach that between instances or between stopping and starting an instance. The EBS volume that I draw out here is not a physical volume, it's a logical volume. Behind each EBS volume, there are many disks that provide us the availability and durability that you'd expect in a block storage service offering. And we give you choices of different volume types to meet your needs. We have magnetic volume types, like the ST1, which is throughput optimized, or the SC1, which is cold storage optimized. We also offer high speed, high performance, low latency SSD-backed volumes, like our GP2 and our IO1 that lets you provision the number of IOs per second you need. With EBS, we support snapshots to S3. The first time you take a snapshot, it'll copy all your blocks of your EBS volume onto S3. Subsequent snapshots only copy what's changed, so you can optimize your costs and have replicas of your data stored in persistent backups. Next, I'm going to talk about networking. How do these instances talk to each other and to the rest of the world? So you may have heard of the Amazon Virtual Private Cloud, or VPC. This is your virtual network in the EC2 or AWS cloud. It has all the primitives you'd expect of a virtual network. It has security groups, which lets you specify what instances can talk to what instances. It has ACLs that tell you what subnets can talk to what other subnets. They provide NAT gateways, which you can attach to a subnet to let it communicate with the internet, and then use network address translation to bring the results back to your subnet. We provide flow logs, which you can enable on any of our network interfaces, like subnets or VPCs, that let you monitor the traffic coming in and out of those interfaces, seeing what's accepted and declined, so you can maintain a high security posture. People tend to look at these flow logs and then adjust their security groups to make sure that they minimize their exposure of their data. Within a VPC, you could add endpoints to AWS services with VPC endpoints. What that means, for example, with S3, is that you can have an endpoint to S3 in a VPC such that all your traffic to S3 goes over the Amazon network. Just this week, we introduced shared VPCs. This allows you to have a network administrator in your organization have a VPC that they manage in their account, and they have the expertise to set up the policies on that VPC, and other groups with other accounts can launch into that VPC. This has been a very common feature request to allow organizations with sophisticated account topologies to work together in a shared VPC. So I mentioned endpoints, especially to S3 and Dynamo. Well, with Private Link, we allow you the ability to have an endpoint from any VPC to any other VPC, such that that traffic doesn't bypass the internal network. You can have Private Link enabled for your own VPCs within an organization, so you can have kind of compartmentalization between accounts, but have these accounts and their services talk to each other according to rules that you define over these endpoints. Or one of the most interesting cases that we've seen is with SaaS providers or ISVs. These SaaS providers have mission-critical and super sensitive data. Imagine Salesforce, who may have all your customer leads. Now, traditionally, if you wanted to go and load those up in a data lake on Amazon, you'd have to hit a public endpoint and bring that over the internet. With Private Link, you could actually drop an endpoint to Salesforce in your VPC, and you address it with a private IP in your VPC, and all that traffic happens over the Amazon network. So we have a number of partners that are excited to enable Private Link, and we have a number of customers who are asking them to enable Private Link so they can take advantage of these scenarios with the security and privacy that they expect and they need to meet their own regulations in their organization. So as your needs get more sophisticated, you're going to see many VPCs in your application. And traditionally, the way that you scale is with VPC peering, where you peer all your VPCs with each other, point to point. You peer each of them with VPNs to reach out to your on-premise data centers or with direct connect gateways. Well, this often led to massive route tables, and they're really difficult to manage. This week, we announced Transit Gateways, which provides a hub and spoke for you to manage your VPCs. You essentially connect each of your VPCs to the Transit Gateway. You connect your VPNs and your Direct Connect gateway to that gateway as well. And now, these can all talk to each other via the Transit Gateway. You don't have to think about overlapping CIDR ranges. Each VPC could talk to any other VPCs according to the policies you defined. And when you add a new VPC, it automatically has access to the other VPCs and the on-premise links. So this was one of the features that got the most excitement from our long-term customers who were dealing with a topology that looked more like the left-hand side of that slide. So let me recap quickly some of the EC2 resources we've talked about. We've talked about AMIs, Amazon Machine Images, which are your virtual machine configurations. This is a software and configuration that you need to launch an instance. We've talked about the EC2 instances, which are running or stopped virtual machines. These are your virtual servers in the cloud. Talked about VPCs. These are your virtual networks in the cloud where you can launch EC2 instances. Talked about EBS. This is block storage as a service. EBS snapshots in S3, where you can persist your storage for having redundancy and backup. Now I'm going to talk about availability. So you've probably seen many versions of this slide. This is the AWS global infrastructure. We have 19 regions and 57 availability zones. Well, what does that mean? Well, our concept of a region availability zone is different than what a lot of other providers talk about. For us, an availability zone is one or more data centers. And each availability zone is miles apart from the other availability zones on different fault domains, different floodplains. They have different power and networking. All of our new regions have at least 3 availability zones. And it's this architecture that allows us to support an SLA of a 99.99% availability on EC2. But there's things that you can do even within an AZ to make your apps more resilient. So we have a feature called placement groups. So when you launch your instance, you can specify whether you want your instances to be launched close together or further apart. In scenarios like HPC, where you want to minimize the latency between your instances, you would launch your instances in a cluster placement group. In your call to launch your instance, you'll say strategy equals cluster, and when we place them, we'll try to place them as close as possible on the network, even in the same rack where possible. But there's some instances where that's not what you want. You want to minimize your chance of correlated hardware failure. And for those use cases, we have spread placement. If you pass in strategy equals spread, we look to have those instances on different fault domains, different pieces of hardware, different racks. And a great example of a spread placement group is if you have a NoSQL database. Typically, these are applications where you need a quorum. You'll have 3 nodes. By putting a strategy of spread in your call to launch these instances, we'll put each node in your SQL database cluster on a unique piece of hardware, such that if one fails, it's less likely that that'll bring down your reads or reads and writes for your application. Another abstraction a lot of our customers, most of our customers use is load balancing. I think you all know what load balancers are. But you can use these to increase your availability because load balancers on EC2 can span availability zones. So you can have an active-active configuration where you have some of your endpoints in one AZ, your other endpoints in your other. The load balancer will look at the health of the AZ, and if it has connectivity issues, if you're not able to get to your workload from one AZ, it'll automatically cut over to the other. We have load balancers that operate on the application layer 7, and with the application load balancer, and that also operate at the network layer for optimizing your performance at the protocol layer 4. Most of our customers, I think it's 97% of our large customers, use ELBs in conjunction with auto-scaling. So a common use case for auto-scaling is you put your instances in what's known as an auto-scaling group. And what that auto-scaling group does is it allows you to have a health check. And it'll look at the health of each of your instances. If one of them fails the health check, it'll automatically bring up another instance to replace it. This is something most of our customers use to ensure that they have a healthy number of instances in their cluster. The other use for auto-scaling is dynamic scaling. This is reacting to patterns of demand and decline. So you may have an ELB with a set of instances and a scaling policy. The scaling policy will look at things like CPU utilization. If you see a spike, we'll bring additional instances on board, and then we could terminate those when that spike subsides. Just this month, we introduced a new capability called predictive scaling. So predictive scaling looks at the patterns of application cycles on your application and across the broader set of applications that run on Amazon, and uses machine learning techniques to predict when you're going to need to scale ahead of demand, and when you're going to need to scale down ahead of seeing those drops. On the left-hand side, that's really your on-premise scenario where you have to really provision to the peak. You have to buy a lot of hardware because you know that you're going to hit that peak, but you're not able to scale up or down because it's on-premises. The middle graph shows kind of what you have now with auto-scaling, where you scale just in time. You see, just as you see demand, you're able to bring up instances. but they may not get there right when you need them. They always kind of drag because it's based on current CPU utilization. And you may have them longer than you need, which is a cost to you. With predictive scaling, we're able to map to that utilization curve. So I'm going to talk about some of the abstractions now that you can use as you scale up your use of EC2 and AWS. So we talked about launching instances, right? Well, when you launch an instance, there's a lot of parameters that you have to specify when you launch your instance. The type of instance, the EBS volume, which AMI do you want, what subnet do you want it in, what's your placement strategy. You go and you supply those to your console or to the command line interface or to an API, and away we go, we launch your instance. We've introduced a new capability called launch templates that lets you encapsulate all those parameters in a template. What this is great for is ensuring a consistent experience in your organization. You can define the launch templates that you want people in your organization using. What instances do you want them to launch? What are the AMIs that you want them to use? What are the subnets and security group rules? And you can prevent them from launching anything outside of those launch templates. You can also choose what fields they're allowed to override. If you have a new configuration, let's say you have a new AMI that has a new patch, you can version your launch templates, have a new one, such that new instances from then on, are launched with that AMI. This is a great tool to have governance in your organization and have a consistent experience across different groups. And these can be used in conjunction with those auto-scaling groups. And that's how most of our customers use them. So there's often times where you have to manage your servers at scale. You have to go and patch them. Imagine Patch Tuesday on Windows servers. Or you have to run a script across them. You have to track the software that's on them. We have capabilities packaged in AWS Systems Manager that lets you do this across your fleet. We even let you connect to your instance via a browser or CLI to a terminal on your instance without even opening up any additional ports. Many of our customers are using Systems Manager to operate their fleet, manage their configuration at scale. So I talked about some of the scenarios where customers have multiple accounts. And they usually do this for billing isolation or security isolation, or they just want to compartmentalize what groups, resources are contained in different accounts. But what happens if you want to share resources across those accounts? What if you have a company and you have an accounting group, and then you have an R&D group, and then you have a sales group, and they all have accounts, but you want to share a VPC with that VPC sharing feature or the transit gateway feature I mentioned. The underlying technology that lets you share those resources under those accounts is the Resource Access Manager, which we launched this week in conjunction with those features. This lets you securely share AWS resources with other accounts and other AWS organizations. Subnets and transit gateways are the first examples of resources that you can share. But we also just yesterday launched License Manager. I'm going to talk to you a little bit about how you can share license configurations across accounts. So excited to announce this feature, and we're excited to have more ability to share resources across your AWS accounts enabled by this technology. AWS License Manager. So many of you have software that you use in the cloud, and then you bring your own licenses for that software. These are things like SAP or Windows or SQL Server or Oracle. And as you're probably aware, these vendors aren't super happy when you don't comply with the terms of that license. And this can be a real pain. It can be expensive. It's a lot of heavy lifting on your end to track these licenses. We've introduced a new service this week called License Manager, which lets you take those license terms, codify those into rules, and then we have a dashboard that lets you see and track how you're doing to optimize your license usage. We can even prevent you from launching new instances, if you so desire, when you run out of licenses. This will really help you comply with those terms, be able to face an audit, and really avoid that audit in the first place. A lot of our customers, especially those enterprise customers, find that this is a real value to them. Not only do we let License Manager manage your licenses on the cloud, but we also will let you manage your licenses on-premise or even in other clouds. So something that our customers gave us a lot of feedback on this week was that was a great capability that they can have one-stop shop to manage their licenses from these vendors. Finally, I'm going to talk about how you can optimize your spend on EC2. So we have a number of different purchase options. On-demand is probably the one that most of you are familiar with. This is just launching an EC2 instance, and you pay by the second. There's no long-term commitments. This is ideal for when you're first trying out EC2, or if you have workloads that tend to be spiky. But we find that most customers, as they use EC2, see the benefit of making a commitment that could significantly reduce their spend with reserved instances. And you could reduce your spend even more by buying spot instances, which is our spare capacity that we offer at up to a 90% discount off on-demand prices. So I'm going to talk about each of these. But the key thing you should think about as I'm talking about them is how you can utilize these three purchase options together in your portfolio to optimize how you consume compute on AWS. So first, let's start with EC2 reserved instances. So reserved instances can be bought in 1 or 3 year terms. They give you up to a 75% discount for that 3-year term off the on-demand price. And these are ideal for your steady-state workloads, your databases that you know that aren't going to go down or that you don't want to go down, your mission-critical systems. We offer a number of payment options. You could pay month-to-month, you could pay some upfront, or you pay all upfront for an even bigger discount. And we offer convertible reserved instances or convertible RIs, where you can buy a reserved instance for a particular instance family, like let's say it's a M5. And then you realize down the road that, hey, we just introduced a new generation, M6. You know what? I want to move all my compute to that one. And you can do that. Or you realize that, you know what? I thought this was more of a general purpose workload, but it seems to be, I seem to need more memory to make the most use out of it. I want to convert these to an R5. With convertible RIs, you can do that. You can choose to reserve capacity in a particular availability zone, or you can have the discount apply across multiple availability zones without a reservation. And most of our customers tend to take that second option because they want that discount to apply as broadly as possible. But there's going to be times where they anticipate a scale-up event. They're going to have a big launch, or they're introducing a new game, or it's that time of month where they need to make sure they have capacity available. For those sort of scenarios, we've introduced a new feature called on-demand capacity reservations, which lets you essentially put a hold on on-demand or RI capacity ahead of when you need it, so you know it's there when you need it, and you can terminate that hold when you're done with that capacity. So let's talk about Spot. Spot allows you to get spare Amazon EC2 capacity at a savings up to 90% over on-demand. So the catch with Spot is that we're constantly looking at supply and demand curves on our fleet. And when demand exceeds supply, we can give you a 2-minute warning and terminate your instance. Now, that rarely happens. Most instances, between 95 and 98% of instances, Spot instances, are terminated by the customer when they're done with their job. But for those fault-tolerant workloads that you're able to have that your app be resilient if your instance is terminated, Spot's a great option for you to save money. And workloads that includes are big data, CI/CD, web services, HPC, where you can really use Spot to turbo boost your application. Instead of having 100 nodes, what if you could get a second 100 nodes on your application for a fraction of the cost? Many customers choose to do that to make their jobs run faster. If some of those nodes get terminated, that's okay. Their job still completes. So we have a lot of customers who tend to use a lot of Spot to get some crazy processing times on things like ETLs and analytics and big data workloads. Another set of workloads that are ideal for Spot are containerized workloads that tend to be fault tolerant already. They're stateless, they're loosely coupled, and we're seeing an increase in the amount of Spot being used for these workloads on EC2. So we've talked about these three purchase options, but you may wonder, how do you use them together? How does Amazon make it easier for me so I don't have to manually kind of keep on looking at my fleet, making sure that I'm optimizing my spend? To address that, we've introduced a new API and capability called EC2 Fleet. This automates the provisioning of capacity across different instance sizes, AZs, and purchase options. And this integrates with the primitives that we already provide, like auto-scaling. What this means is that I can say, I want an auto-scaling group to run my ETL process. I wanted to have a minimum of 50 instances on demand because I need it to definitely complete by tomorrow morning. But if there's additional Spot capacity available, I'll take as much of that as I can get, or up to a certain limit. So let me also put in a parameter that says I could also take some additional Spot. And you know what? My workload doesn't have to run on M5. It could run on M4. It could even run on R5 if it's at a sufficiently low price. So I have flexibility across instance types. So I can encode all that in a set of rules and launch my auto-scaling group with those rules. So behind the scenes, we'll dynamically provision those 50 on-demand instances. We'll look at your price parameters and your flexibility, and we'll provision the additional Spot that you need to accelerate your workload. And as more capacity becomes available, as your job needs more compute, we'll dynamically manage all of this on your behalf. So this is something that a lot of our customers are excited about because it takes away the heavy lifting of trying to decide how to optimize the most of your compute. So to sum up how you can optimize your spend on EC2, we recommend that you use RIs for known steady-state workloads, your mission-critical apps, your databases. On top of that, you layer on-demand for unknown spiky workloads. And then you can leverage Spot for your fault-tolerant, flexible, stateless workloads, or to accelerate your workloads by adding more nodes. One feature, I think it's the last feature I'm going to introduce today, that actually makes this easier and helps you even save even more money is Hibernate. So we launched Hibernate for Spot last year, but this year we've announced it across on-demand as well. What Hibernate lets you do is spin up an instance, get it all ready, get it all booted up, all the memory is where you need it, and then you can freeze it, hibernate it to EBS, similar to the way what would happen when you shut the lid on your laptop. And then when you're ready to go and you want to spin up more instances, you can spin them up from that hibernated image and have them ready to go without having to boot them up. Some software packages take a while to boot up. They can take minutes. It takes a while to initialize them. Now, with Hibernate, that can be instantaneous, which will even increase your utilization even further, since you're not waiting for these machines that are brought into these auto-scaling groups to get to the state you need them to be operative. So really excited about that and how that could help customers save even more on their costs. So with that, I want to finish up the talk and kind of recap some of the main points. We talked about EC2 resources. We talked about instances, storage, and networking that go along with it, and the different types of resources to meet the needs of every workload in the cloud. We talked about how Amazon builds our data centers to be highly available and the best practices that you can use to make your workloads resilient on the AWS infrastructure. We talked about some of the tools and abstractions that we provide as you scale up your use of EC2 to help you manage, deploy, monitor your EC2 and compute usage and instances. And we talked about how you can optimize your spend on EC2. So thank you all for coming, especially on Friday. I hope you learned something today. I'm really excited to be here, my 5th reInvent, and I hope to see all of you next year. I'll be available for questions in the corner. Thanks so much.